My name is Matthew Daniel. I am the 48-volt product manager at the Fortress Power, and I am very excited to present the new 48-volt battery called the eBoost. And before we get started with our presentation, we wanted to sort of give context to the release of the eBoost, right? Fortress Power, we found out that our customers were really happy with the eForce battery, but we certainly wanted to bridge the gap. The eForce battery is a 9.6 kilowatt hour battery, stackable to 19.2 and up to 28.8 vertically. But for those solutions that are looking for an intermediate between the 9.6 kilowatt hours and 19.2, the eBoost is a perfect solution. We took everything that the installers love about the eForce and compacted it into this solution, where this battery will certainly meet the average home load demands, as well as packing a punch for its capacity. So let's get started with it. Here, as you can see, this is the eBoost on the left side, right? It's comprised of two parts, right? You have the eBoost module, which is where the battery cells are held in the BMS. It is a 16 kilowatt hour battery, so 314 amp hour cells. And then you have the top part, which is the eBoost E-Way, which is short for electrical wire way, the same way that we do for the eForce, right? Now, as like the eForce, it is a IP65 outdoor rated solution, perfect for outdoors and including climates with cold temperature, since it has integrated heaters that only consume 325 watts. It is providing the ease of installation when sort of rolling it into a garage setting or through a paved concrete pavement, where it has included wheels. So you can sort of wheel the battery to the installation site and installation location, right? So it certainly provides a ease of installation for our customers. We sort of got the feedback from the Evo Max that the Evo Max was a heavy boy, right? It's an 18.5 kilowatt hour monolith battery, but as soon as you got it out of the box, it was the most easy to install battery in the market, and we're doing the same or more with this solution as well, right? It is compatible with the NV8K, 10K, and 12K and NV Duo, but not just obviously in terms of functionality, but also stackability. You can stack the NV on top of the battery through the E-Way top cover compartment. You can parallel up to 16 of these units, totaling a total 256 kilowatt hours, where each module will use an E-Way, regardless of how many batteries you're using or how many inverters. You would need an E-Way that provides an Amphenol connector. So take the E-Way, just sit it on top of the battery, 2 bolts on the side, on the left, on the right, and you're done. It is a 16 cell battery, so 51.2 nominal battery, and it provides indication, right? Indicators for the customers, front LEDs and back LEDs, very similar to the eForce, where I'll talk more in details about the functionality. So why do we say the battery is the most powerful 16 kilowatt hour battery on the market? Due to the research we've done and studying, we noticed something very peculiar, and it's that this, a lot of the solutions out there are providing the same kilowatt hour battery, 16 kilowatt hour batteries, but with shy of below 200 amps of current charge and discharge. Now, we all know in the market that the typical household will use an average of one 12 kilowatt inverter. Due to the pass-through functionality, right? Other people use other different brands and have a different naming system for it. But overall, a lot of these 200 amp pass-through inverters are the majority 12 kilowatts of true backup, right? Where that really will demand from the battery at least 230 to 250 amps if the loads surpass or reach 12 kilowatts. So a lot of these solutions out there would really need to put not one, but two batteries to meet the load demand of the customer. Whereas with the eBoost, with one battery stacked, or with one battery with the inverter stacked on top, you will meet those load demands, right? It is able to charge at 180 amps DC and discharge at 250 amps DC continuous, right? Max continuous, with a peak surge of 16 kilowatts for 10 seconds. So it's a very, very powerful battery for your continuous usage without any glimpse or issues. Now, what do we want to solve with the eBoost? Same with the eForce, right? We want to save. We want to do huge savings, right? There's a lot of regulations and policies being put into place where, you know, a lot of these solutions have to be very more cost effective, and the eWay solves that in a lot of these installations, right? You don't need conductors, you don't need a bus bar, and you don't need a wireway, and overall you're saving a lot of time and exponentially hundreds and hundreds, if not $1,000 in your installation. With that, we provide 10 years of warranty, okay? This 10-year warranty coverage on all manufacturing disperfect or you know, anything that happens wrong with a battery with that period, we have solutions that we provide. If it's a cell imbalance, we provide a new battery. It's what we've done always. As you can see, the battery solves a lot of the aesthetic form factors, or is perfect as an aesthetic form factor for a lot of the jurisdictions and new regulations that are coming up, right? You have NEC code, or you have the applications where batteries have to be installed 3 feet above the ground. This certainly would meet that, where the disconnect is not higher than 6.7 feet, and would save the installer having to install bollards when installed inside a garage, right? And it will meet UL 9540 DC ESS, okay? I will go more over sort of the definition of the UL 9540 DC ESS, because I know while that has been implemented in 2023, some people are still new and unfamiliar with the differences, so I'll go over that. It is easily, you know, upgradable. You know, if you wanted to expand your capacity, you just put the battery on the side, put a couple of pair of cables from bus bar to bus bar, as long as you do that within the 2-year period. And it is inverter agnostic, right? Since it has the ULDC ESS, it will be able to couple not just with our Fortress Power solutions, but any other solutions that you understand that fit better your needs. As long as that solution is approved for UL 1741, you should be good to go per the UL DC ESS standard, right? So the battery itself has 2 indicators, right? You have the front LED. The front LED gives you, starting from the bottom bar, right? It's a 25% state of charge indicator, 50%, 75%, 95%, and that little dot is 100%, right? Then you have an outer frames, which basically let you know if there's battery-to-battery communication. If there is battery-battery communication, then both of those will be lit up, right? And then if there is a fault, right? So if there's a fault, you will see this light up and everything sort of black, signaling to the customer and to the installer that there is a fault or an alarm occurring, right? And you will get two double confirmations, right? So you will get it from the LED, and then you would also get it from the back LED. So the customer or this battery will provide a back LED where if it's normal, it's going to light up white. If there's a fault or an alarm, it will light up yellow, okay? Now, as I mentioned before, a lot of this battery will certainly meet a lot of the NEC codes and UL standards. It will meet NFPA as it's below the 20 kilowatt hour capacity per unit. It won't have any exposure conductors, right? Because we made the wireway so that you have side knockouts, so you can run wires from one side to the other through conduit and just create a safety, right, within the premise. So I will now talk about the UL9540 DC ESS, right? To give a little bit of context, you know, the UL before used to certify the batteries in this manner. It had to be UL9540 on the first edition, and it would just certifying the battery. On the second edition, the UL9540 certified the batteries with, you have to certify the batteries with an inverter, right? So both solutions had to be implemented and certified under that standard. On the third edition, they've changed a little bit of the definitions, and they sort of included both solutions, right? So when we're talking about ESS, it defines it as an equipment in one or more enclosures that receives energy and then provides means to store that energy in some form or for later use in order to supply electrical energy when needed. And it can be either AC ESS or DC ESS. And basically summarizing, you know, both definitions, the AC ESS basically is an ESS that gives an AC output. The DC ESS is a ESS that gives a DC output, where to differentiate from the AC ESS, the DC ESS, the inverter is a subcomponent of the system, but not part of the ESS. And I know a lot of regulations or a lot of jurisdictions, including CEC, are implementing a lot of these. Currently, I know PG&E is working through that as well, since it's sort of new in the market. People are still sort of accustomed to the ACESS solution from the second edition, but you will see a lot of solutions moving to this just because it's more flexible, right? All right, so let's talk about the E-way, right, which is the top compartment that, you know, closes the circuit on the monolith battery. So the E-way, Fortress Power E-way, you will see internally it has a 750 amp bus bar, perfect to pair battery to battery and then battery to inverter, right? It has the communication board right here. So you open the door, it opens from right to left, and immediately you are granted access to this compartment where you will see this board that is just sort of like a common board. It's not a BMU, right? As I mentioned before, the BMS is integrated within the battery module. This is just to pair all communications together from battery to battery and then battery to inverter, right? Then you have the side disconnect, which serves as a rapid shutdown switch. So for NEC code, they are mandating that not only PV is de-energized, but that your entire system is de-energized. Your inverter's AC output, your PV, and your battery's voltage output. And that just creates and enhances a safety factor, right? Both of this switch and the latches of the door of the E-way are lockout and tag out friendly. As long as you use a lock that's 6 millimeters, which is the exact measurement. It has side knockouts, and it includes a DIN rail to include the Guardian, which is Fortress Power's monitoring hub, in order for you to see all the intricacy details of the battery, state of charge, voltage, current, not just on a single battery, but all batteries parallel together. You would only need one per system. Okay. It is scalable, like I said, up to 256. So that's 16 in parallel. Okay. It measures about 22.84 inches wide, 47.33 inches tall, and then 10.18 deep. So if you consider our previous solution, which was the eVolt Max, 2 of these is almost as the same form factor for the eVolt Max, but you have double the capacity. So 32 kilowatt hours versus 18.6. And then each module will weigh about 308 pounds. That's including the e-weight. So it is doable. It is manageable for sure. Disregarding the e-weight, right? Now, we do also provide a solution, which is a more cost-effective solution when you're doing certain types of installations with the ENVI or other inverter partners, where you don't necessarily need a lot of the bells and whistles that the e-weight includes, right? So to get to it, on the left side, you have the e-weight and everything that it includes. And on the right side, you have the e-weight Lite, right? So the difference is the e-weight has a top compartment where it allows for the inverter to sit on top, right? And not all the e-weights need this solution, right? It has a 750 amp bus bar, as I mentioned before, and the e-weight Lite has a 250 amp bus bar. So it's perfect to just pair it to this bus bar if you were to install it on the side or on the front, as you see in the picture. I made an oopsie here. This actually is inverted. Here we go. Sorry. My apologies. So yeah, so the e-weight would not include that top part compartment. I apologize. This that I have to flip. There you go. Basically, this is swapped. So the e-weight, traditional e-weight, will include the back knockouts with a status indicator, and the e-weight Lite would not. That's essentially what I was trying to get at. My apologies for that. And on the side, then you have the disconnect, which is the rapid shutdown, which is not really necessary for the e-weight Lite, particularly because when you're paralleling, you only need really one disconnect to shut down the entire system, right? And then both of them have the power on and off push button on the side. But all in all, that rounds up to being more cost effective when purchasing the e-weight Lite for parallel solutions or for solutions that really don't need any of these features. So these are some spacing requirements per the UL certification that will be released October 31st. So what we require is that each battery is spaced about 5 inches and the inverter 8 inches. If you were to parallel ENVI with ENVI, just for better heat dissipation. And then 3 feet, anything, have a clearance of 3 feet in front of it, and then 1.5 inches from the battery to the wall, which is already it's already done for you. You don't have to do that measurement since we include some brackets to install against the wall. So these are the acceptable floor mounted configurations, right? You can stack the ENVI on top of a battery, or you can stack the ENVI on the side of the battery, which in this case, that would be a perfect solution if, again, not a lot of the systems require necessarily that disconnect or that top compartment where the ENVI sits. You can just sort of stack the inverter on the side, right? And then option 3 is installing the battery right in front of the other battery. What we don't accept is having one battery with two inverters, regardless if it's the 8K, 10K, 12K, or NV Duo. And it's because you would be undersizing your battery system, right? You would be overloading current. So each 8K is about 167 charge and discharge. Then 10K is about 210 charge and discharge. And the NV Duo and the NV12K would be 250 amps of charge and discharge on the battery side. So two of those, regardless of the size, would be undersizing your battery. These are the acceptable wall mount configurations, right? You have an NV stacked on the battery and they're wall mounted, or you have the NV on the side of the battery, right, where they're both also wall mounted. What we do not allow is stacking the battery on top of the other battery, right? We don't want that wall to break, and we certainly don't want that battery to break. So no stackability in front of each other. Okay, now we're gonna get to the unboxing. So you will receive, right, the module is a box like this, right? You have arrows pointing up. So when you bring it to the site, very important that you have those arrows sticking up, because that will be the orientation of the battery, right? So all you do is, open the battery right in the middle, take all the accessories out, and then slide the battery forward. So pretty easy. And then this would be your items that you would receive, right? So on the eBoost box, you have the battery module, right? You have the template, right? That will allow you to facilitate the installation a lot quicker, faster, and more precise. Battery to battery bracket. So when you're installing front to front. Battery to wall bracket, right? So when you roll it against the wall, install that bracket. It's an L-shaped bracket that gets connected to the battery and against the wall. Nuts and bolts, and then the eBoost E-way will include the E-way, the manual, a cable separator that allows you to isolate your AC conductors and your DC conductors inside the chamber. Communication cables for battery and battery to inverter, and then the relay cable, which allows you to which allows the battery, like the primary battery, to signal to the other secondary batteries to turn on when everything is being commissioned. And then some nuts and bolts as well. So moving into the installation, the only tools you'll really need is your basic electrician tools, which is, cable lug crimper, stripper, electrical tape, and a multimeter, right? Along those lines. Personal protective equipment, and a socket wrench, a drill with drill bit set, a dolly or a hand truck to facilitate the moving of the battery inside the box, and then a screwdriver set. That's it. So very, very easy, and no special tools needed. So to comply with this configuration, right, where you have the battery and the inverter stacked on the top, you start by installing the S-shaped bracket with these 4 screws against the back of the battery. Okay, then you line the battery against the wall and put the template on top of the S-shaped bracket. Make your holes, right? So holes for the wall to fixate the battery, and holes for the NV inverter, right? So this template will let you know what orientation it is. If it's a 12K, it's gonna say, the marks that you have to make for the 12K, or the 8K and 10K for the 8K and 10K. Okay, stack the eBoost on top of the, or stack the E-way on top of the eBoost, and then secure it with these 4 bolts on the side, and then remove the top cover, to encompass the MV. Remove the bottom cover of the MV, right? Install the wall mounting bracket, and then install the MV on top of the wall mounting bracket, and then secure the bolts on top of the E-way, right? So secure this the MV with the E-way in order to create that nice seal for outdoor applications. And then finally secure the L-shaped brackets from the MV to the wall. Pretty simple. Then you would run your cable, right? Your conductors, your 3/0 conductor to your MV from the E-way's bus bar. Your communication cable, which would be your battery to inverter communication cable, running from this side all the way to the communication board of the MV, and connecting it to the cable MV adapter that's included already with the adapter. And then it has a terminator, right, that terminates the communication of the battery. And this is primarily used when you're also communicating battery to battery. It's basically a little resistor that's inside of an RJ45 plug. And then you have the guardian cable, which you may or may not use, but that's already plugged in for you, where you just have to unbox the guardian and connect it to the plugs already included into the E-way, right? And then lastly, basically secure the wheels, right? So you screw it to the right, and then it basically fixates the battery against the floor, and all said and done, right? Now for this configuration where you're stacking the battery in front, what we typically do is we suggest using liquid tight flexible conduit to go from one side of the E-way to the other side of the E-way, right? This will facilitate anything that needs to be done to get back to the other E-way. So if something were to happen, let's say servicing needs to happen, this will allow me to sort of take the brackets from the second battery right in front, move the battery without having to go through so much hassle, right? Because it has wheels included. So yes, we recommend using flexible conduit. And then to achieve this in this configuration, basically you dismount the included wall-mounted bracket. Yes, we include the wall-mounted bracket with the eBoost module, each eBoost module. But so you would take that out. Basically, it's 4 screws on the side, and then install this battery-to-battery bracket to the back of the first, or to the back of the lid of the first battery. And then secure the back of the second battery as such. And then this would be sort of a parallel overview of how you would basically communicate the batteries if you were in parallel, starting with the electrical cables, right? Each electrical cable would go into the 2 battery ports of the MV Duo or MV12. Right. In the case of an 8K or 10K, then you would just parallel both bus bars to each other. And then from there, you would run it to the inverter terminals, since the 8K and 10K only have 1 battery terminal. Then you would connect the battery to battery communication cable from E-way to E-way. And then the relay enable cable, which is basically the one that allows for all batteries to shut down when you enable rapid shutdown per NEC code, or all the batteries to turn on when you initiate the primary battery. And then the communication cable that goes from primary battery to the primary inverter, right? If you have multiple inverters in parallel, then it will go to the primary inverter. And then the cable that's already, included with the E-way, you would just hook up the guardian to that cable, essentially. This is a configuration for when you want to stack the battery or the inverter on the side and you want to run conduit to one side. These are sort of the measurements that we give out, right? This is all in the manual, so you can obviously take a look at your leisure and at your time. But this basically lets you know what the distance would be in order for the MV to align with the side knockout of the E-way. And so you would only really need to use a 1.5 inch conduit to go from side to side, and you don't need any reducers when you're using the MV Duo 21, the MV 12K, 10K, or 8K. Wall mounted configurations. This is basically a guide to let you know how high you can install your system before you violate NEC code, essentially, right? NEC code doesn't allow for the disconnect or the highest disconnect at the highest position to be above 6.7 feet. And so basically this is a guide to let you know how high you can put it before you go to that limit, right? And this is for both 21, MV Duo 21, MV Duo 12K, MV 8K, and 10K, right? So if you wanted to do a wall-mounted configuration, basically you take the included wall-mounted bracket, you put it against the wall, you make your marks with a leveler, and then drill, secure it, and then lift battery, and hang it against the bracket. And lastly, 4 screws that goes, 2 screws that go on each side of the battery to secure the battery with the bracket to avoid any horizontal movement. Commissioning. Simple steps. Turn the battery breaker at the inverter side, right? So, and we always say that because regardless of any inverter or disconnect you may use, when you're doing it the other way around, energizing the battery and then flipping the breaker, you might create arc issues or that might or might not affect. We haven't seen that necessarily on the Envy, but I always recommend doing it just for safe practice. And it's a standard practice, right? So flip the DC breaker up and then turn the rapid shutdown turn the switch to the on position, right? Doesn't mean that you're initiating rapid shutdown. It means this means rapid shutdown and off. So if you wanted to actually do rapid shutdown, you would turn it to the left position. So turning the battery on, flip it to the right, and then energize with the power button on the bottom. Okay, on the when you have multiple systems in parallel, let's say that for whatever reason, maybe you have 3 inverters and you have 3 eBoosts, and so you wanted to stack the MV on top of that eBoost, each stack. In that case, you would basically be using the regular E-way. And in that case, you would only be energizing the primary E-way, and that will signal to the rest to turn on. Obviously, following the same procedure as turning the battery breaker on the inverter first. Then you energize the primary battery, which will signal for the rest to turn on. Once you do that, then you hold the button for 5 seconds. And you get to select the protocol. So the default protocol that comes integrated already in the battery is Fortress Power by default. But if you wanted to use other, inverter manufacturers, that would be the way to do it. So you hold it 5 seconds, release, it's going to blink, and it's going to let you know in what status it is. So typically, or by default, it's going to blink this and then blink this. If you press it again, it's going to blink like this. right, to select the inverter. And then once you get to the inverter that you want, you basically just leave it for 10 seconds and it's going to go back to its normal status. Well, normal operating status, right? Okay. Closed loop. How to achieve closed loop, right? We energize the battery. We energize the inverter. Now we're going to do closed loop with the inverter. Set the inverter in standby. Right, this is how it's going to look like in standby if you're grid type, right? It's going to do AC pass-through, assuming you have whole phone backup. Then you're going to set your grid type, your grid regulation, and then on the battery type, you're going to select lithium, and then it's going to say lithium brand 18. Now, typically, this should be coming like this by default, but if you're using another solution, then this would be the way to select your lithium brand. Can I use the eBoost with eForce in parallel? No. So the eForce, so two things. There's a yes and no question to that. eBoost and the eForce have different cell configurations. eForce is a 15-cell battery. The eBoost is a 16-cell battery. However, if you do, which is a feature that we've experimented a lot, we've deployed a lot, and it's proven functional and ready, is the do not share feature battery that the NV inverter has. And what does that mean? It means that I can run electrical cable from my battery directly to my inverter. If you have, let's say you have three NVs and you have 3 eBoosts, let's say. I don't have to parallel eBoost between eBoost and eBoost. I can just run conductors straight up into the NV as long as it's a single split phase application. And then you have AC charge, which is grid charge, or a generator. Because naturally speaking, in that configuration, your SoC might drift away, right? Given that you're not going to have the same amount of PV on one inverter than the other. So batteries are going to be charging differently. In that case, what we do is integrate a generator or the AC charge so that when a certain battery, let's say battery 1 from NV1 and battery 1, discharges to 25% and it reached the start charge before the others, then that battery is going to get the power as well as the others as well as the others. So that is a proven way that in that configuration where a pair of electrical cables is not being shared between bus bar and bus bar doesn't drift. So the answer to your question, if you had 2 NVs, then yes, you can do an eBoost on one side and an eForce on the other side because they're not electrically seeing each other. The communication cable from the eBoost would go to the primary inverter, as well as the communication on the eForce, BMS communication would also go to the secondary inverter. So hope that answered your question. Is it ground mountable? Not like the eForce where you anchor the base. You just fixate it. The thing that would be touching the ground would be the wheels, but it would be secure with the L-shaped brackets against the wall. Does it work with the Solis 1P10? I'm not familiar with the inverter, but assuming it is a 48-volt inverter, as long as, so in terms of BMS communication, that would be something we certainly have to test. But if the Solis meets the battery charging voltages, that it goes between 48 volts to 56 volts, then it can work in open loop, no issue. Now, that will be all for today's presentation. But we do have a video that I invite you to look at in our YouTube channel, right? It's the eBoost installation video. It will basically cover everything that I've just mentioned in a step-by-step, easy to understand procedure. But if you are requiring more information, you can certainly go to www.fortresspower.com under the product section where we have our manuals, data sheets, and we'll be uploading our certifications there as well. I hope you've enjoyed this presentation. Thank you so much. I know the eBoost is just going to be one of those batteries that's going to defy the market. Safe. It's certainly the most robust battery in the market for your average inverter use. And you definitely have our 10-year warranty all-in-one solution with Fortress Power. We're just one phone call away to help you and guide you. Thank you very much.